Okay, so this is lesson 7.8, which is finding the interior angle measurements of polygons. So we're going to do a little bit of an investigation first to kind of get an idea as to where this equation comes from that we're going to be using. That way you can always recreate it. So first let's break it down. What do we know about the sum of the interior angles of a triangle? So we know the sum of the interior angles of a triangle will always add up to 180. So this angle plus this angle plus this angle will always equal 180 degrees. Okay, the three angles. So what we're going to do is, since we know the sum of the interior angles of a triangle, we're going to construct diagonals from just one vertex to all remaining vertices to construct triangles. Also name the polygons. So I've already named the polygons. I'm going to pick a vertex that I'm going to go from on all of these. So just one vertex. And then I'm going to draw diagonals to all of the other vertices. So for example, I would draw one here, but that's actually just a side length. And then I'll draw one here. And then I draw one here. So I've constructed two triangles. A quadrilateral is made up of two triangles. Now we can do the pentagon. That would be a straight line. There. And there. So in the pentagon, I've constructed 1, 2, 3 triangles. I'm going to do something with this in a moment. 1. Okay, constructing diagonals. Missed that one a little bit. 1, 2, 3, 4 triangles. And again, each of these, the angles add up to 180. So in other words, this angle plus this angle plus this angle adds up to 180. And then this one plus this one plus this one will add up to 180. Then, as you see, I'm really what I'm doing is I'm breaking up the angles that are already created in here into little pieces. And one more. So what you see is that what we're trying to do is we're trying to figure out what do all of these angles add up to. And so if we know if each of these triangles is 180 degrees, then we can figure out what all of those angle measurements add up to. Okay, so let's finish up with the heptagon really quickly. Then we'll continue with our investigation. Last one. The octagon that has 8 sides. Okay, so now moving on to the next page, I kind of move this like this. Okay, so the question is right now, we're trying to figure out a formula to find the sum of the interior angles of a polygon. So again, this angle plus this angle plus this angle, this one, this one, this one, what do all of these add up to? We know for a triangle it's 180, but what do the other ones add up to? And we're trying to figure out an equation. We're trying to create a rule. Okay, doing an investigation. So a triangle has 3 sides, and that includes one triangle. Okay, so that means that it adds up to 180. Okay, a quadrilateral is made up of 2 triangles. So this 180 plus this 180, right? So it's 2 times 180, which equals 360 degrees. Again, we're trying to figure out how do we relate the number of sides to the sum of the triangles. So how do we get from 4 to 360? And we're looking for a pattern. A pentagon has 5 sides, and we made 1, 2, 3 triangles. So again, this 180 plus this 180 plus this 180, what does that add up to? So it's 3 times 180, which is 720 degrees. So what I'm noticing right now is I know that I'm multiplying by 180. Okay, and I'm going to do that all the way down. Okay. Hexagon had 6 sides, and we created 1, 2, 3, 4 triangles. 6, and there are 4. So 4 times 180 degrees, which is 900 degrees. So now can I see a relationship between these two numbers? 3 to 1, 4 to 2, 5 to 3, 6 to 4. So what are we doing? We're always subtracting 2. So before I go and count, I'm guessing, I'm going to infer that there are going to be 5 triangles. 7 minus 2 is 5 in a heptagon. 1, 2, 3, 4, 5. Look at that. And in an octagon, there are going to be 6 triangles. 1, 2, 3, 4, 5, 6 triangles. So no matter how many sides there are, the number of triangles we can create will always be minus 2. So we're going to take the number of sides and we're going to subtract 2. Okay, so then 5 times 180, because each triangle is 180 degrees, which is, oh sorry, this one is 900. And then 6 times 180, which is 1080. So what we're always doing is we're taking the number of triangles, which is n minus 2, the number of sides minus 2, and then we're multiplying it by 180 degrees. I see now where I messed up. So what will the sum of the interior angles of a 100gon be? Well, in a 100gon, I would take away 2 from the sides, right? So it would be 100 minus 2, which is 98, and then I multiply that by 180. That is our formula. The sum of the interior angles of a polygon is, I'm going to write as sum I, big S with a little I, sum of the interior is n minus 2 times 180, where n is the number of sides. And just to annotate this really quickly, n minus 2 told us the number of triangles in the polygon, right? And then each triangle is 180 degrees. Okay? So let's do 2 quick questions together, and then you'll move on and do the check-in questions. So what is the measure of each interior angle? Okay, so I want the measure of one angle, right? Of a regular means that it's equal angular and equal lateral. Of a regular hexagon. Hexagon has 6 sides, so n equals 6. Okay, so this is kind of a 2-part question. We're actually finding the measure of one angle. So what we're going to do is we're first going to find the sum of the interior angles using n minus 2 times 180. So we'll do this at n equals 6. So it'll be 6 minus 2 times 180. 6 minus 2 is 4. And 4 times 180 is 720 degrees. So the sum of the interior angles of a hexagon is 720 degrees. But we don't want the sum, we want the measure of each angle. And since regular heptagons or regular polygons in general are equal angular, that means that all angles are congruent. So a hexagon 3, 4, 5, 6 has 1, 2, 3, 4, 5, 6 angles. It will always have the same number of angles as sides. So one angle will be equal to the sum of the interior angles divided by the number of sides, right? Because if we know that all of these add to 720 and each of them is congruent, then we can just divide by how many angles there are, and that will give us one angle. So the sum was 720, and we're going to divide that by the number of sides, which is 6. And 720 divided by 6, you can do the math, I already did it, is 120. So one angle will equal 120 degrees. Okay, watch that again if that was a little bit confusing. Going to move on. We need to solve for x. Okay, so what I do know is that I can add all these together, and that will equal the sum of the interior angles. So 90 plus x plus 5 plus x plus x plus x plus 5. So 90 plus 5 plus 5, that is 100, and x, 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 x. I have 4 x's. So I know that the sum of the interior angles is 4x plus 100. But what are these actually summed to? I need to go to the side. I need to do a little bit of scratch work. I need to figure out what the sum of the interior angles of this polygon is. So this polygon has 1, 2, 3, 4, 5 sides. So I'll do 5 minus 2 times 180, which is 3 times 180, which is 3 times 180 is 540. So I know the sum of the interior angles is 540 degrees. So I'm going to substitute this in for sum of the interior angles, 540. Subtract 100 on both sides. 440 equals 4x. Divide both sides by 4, and 440 divided by 4 is 110. So just to review that again, I can add all these up to figure out what this angle plus this angle plus this angle plus this angle plus this angle equals, which was 4x minus 100. But I also need to know what those actually sum to, so I had to do the sum of the interior angles so that I can solve for x. Again, if this is confusing, make sure you rewind and play it again.